Hello student, welcome to my channel. Last day we came to know about the topic periodic table and periodicity of the property of the elements. Today we are going to discuss about metallurgy. Now, what is metallurgy? The various processes involved in the extraction of metals from their ores and refining are called metallurgy. Now, what is minerals? The naturally occurring metallic compounds found in Earth's crust are called minerals. Ores, the minerals from which a particular metal can be extracted conveniently and economically are called ores of that particular metals. Now, the question is very important. All ores are minerals, but all minerals are not ores. Explain this. The answer is hematite Fe2O3 and iron pyrites FeS2 are both minerals of iron, both of which contain high percentage of iron, but the cost of production of iron from iron pyrites is very high, as the removal of sulfur is a very difficult process, whereas from hematite Fe2O3 iron can be extracted conveniently and economically. So iron pyrites is not recognized as the ore of iron, but hematite is recognized as ore. Thus, we can say all ores are minerals, but all minerals are not ores. Now, another term, gangue. Earthly impurities including silica, mud, etc. associated with the ore are called gangue or matrix. Flux. A flux is a substance that is added to the charge in a furnace to remove the gangue. Flux combine with the gangue or matrix to form a fusible mass called slag. Now, what is slag? It is the fusible product formed when flux reacts with impurities gangue or matrix during the extraction of metal. As for example, silicon dioxide is a gangue or matrix when react with CaCO3 flux. These two are combined to form CaSiO3 calcium silicate slag plus CO2. Now, what is melting? It is a process of reducing the roasted oxide ore and removing the gangue with the help of an appropriate flux added with the ore. It reduces the oxide ore to metals in the molten state. Now, what is roasting? Roasting is a process of strong heating of sulfide ores to convert them into respective metal oxides. Now, what is calcination? Calcination is a process of strong heating of carbonate ore in limited oxygen to convert them into respective metal oxide. Now, there is a flowchart of extraction of metal from their ores. At first ore, then crushing and grinding, after that concentration, and after concentration roasting and calcination, and then reduction. After reduction we can refining the metals, and after refining we get the pure metals. Now we can discuss about the uses of iron, copper, zinc, aluminium. At first, the uses of iron. Iron, there are three types of iron are possible. That is the classification of iron on the basis of carbon impurities, and their uses are: the first one is cast iron, highest carbon content 2 to 4.5%, and it is very hard and brittle. It is used in foundries for casting metal objects such as pipes, railing, weights, heavier parts of machineries, etc. The second part is steel. It contains 0.15 to 1.5% carbon impurities. It is used for making wheels of railways, cars, bridges, shores, machine guns, different types of wear weapons, engineering goods, plates, springs, for making bar magnet, etc. And the last one is very pure form of iron. It is wrought iron. The carbon impurities, the quantities of carbon impurities is from 0.10 to 0.15%. It is used to prepare wire, making chain, anchors, electromagnets, nail, etc. Now we discuss about the uses of copper. Now we discuss about the uses of copper. Copper is extensively used for making wires for electric wiring and making switch and plugs, for making boiler, water baths, pipes, condenser, copper powder, used as catalyst in chemical industries, for making coins and alloys like brass, German silver, bell metal, etc. Zinc. The uses of zinc are: it is mainly used in the process galvanization, that is to give a thin coating of zinc on the surface of iron objects. Number two, zinc granules and dust are used as reducing agent to prepare dry cell, that is battery, to prepare alloy. And the last one is aluminium. What are the uses of aluminium? Aluminium mainly used as light metal. It is used for making body of motor cars, aeroplanes. It is a good conductor of heat and electricity, and are used to make cooking utensil, electric wires, etc. Aluminium powder is used for making paints and fireworks as a reducing agent. It is used to wrap cigarettes, chocolates, and medicines, and it is used to prepare many alloys. Now, what is alloys? Alloys, a homogeneous or heterogeneous mixture of two or more metals, or a metal and a non-metal having different characteristic properties than the constituent elements, is called an alloy. Now, some important alloys and their uses. The first one is stainless steel. The composition or content of stainless steel is iron 85%, chromium 13 to 14%, nickel 0.7%, and carbon 0.3%. It is mainly used as surgical instruments, household utensil, cutlery, furniture, etc. Invar, iron percentage is 64, nickel 36, carbon 0.3%. Precision instruments, clocks, seismic creep gauge, valves in engine, large aerostructure model, etc. Alnico. The composition of alnico is iron 60%, nickel 20%, aluminium 12%, cobalt 8%. It is mainly used as permanent magnet, microphone, electric guitar, electric motor, loudspeakers, traveling wave tubes, Hall effect sensor, etc. Now brush. What is the composition of brush? Copper 60 to 70%, zinc 30 to 40%. It is mainly used as utensils, hardware, plumbing articles, etc. Bronze, the composition is copper 90%, tin 10%. It is used as utensil, coins, statue, etc. German silver, copper is 50%, zinc is 30%, nickel is 20%. It is mainly used as utensils, flower vases, resistance coil, etc. Bell metal, copper is 80%, tin is 20%. It is used to prepare bell, utensil, coins, sculpture, etc. Gunmetal, the composition of gunmetal is copper 85%, zinc 5%, tin 10%. It is used as gun, arms, etc. The next alloy is magnesium, aluminium 98%, magnesium 2%. It is used to prepare balance, machine parts, etc. And the last alloy is duralumin. The composition of duralumin is aluminium 95%, copper 4%, magnesium 0.5%, and manganese 0.5%. It is mainly used to prepare aircraft parts, boat, machineries, etc. Now, what are the utility of alloy or properties of alloy? Alloys are stronger, have greater tensile strength, are less reactive than the individual constituent metals or non-metals, less susceptible towards corrosion and weathering. Now, what is amalgam? When one constituent metal of an alloy is mercury, then it is called amalgam or mercury alloy. What are the uses of amalgam? As electrode it is used, and the example is zinc mercury alloy. In the dental treatment, silver mercury alloy, and to prepare of mirror, tin mercury alloy. Now we discuss about the major ores of iron, copper, zinc, aluminium. The first one is iron. As oxide, red hematite Fe2O3, magnetite Fe3O4, brown hematite 2Fe2O3 3H2O, and as carbonate, the important ore is siderite FeCO3. Now copper, the ores as oxide is cuprite Cu2O, as sulphite copper glans Cu2S. Another name of copper glans is chalcocite, and the last one is copper pyrite is Cu2S Fe2S3 or CuFeS2. The next one is zinc. As sulphide, zinc blend ZnS, as oxide, zincite ZnO, as carbonate, calamine ZnCO3. Aluminium, as oxide, bauxite, it is very important ore, Al2O3 2H2O, gibbsite Al2O3 3H2O. As fluorite, cryolite is another ores of aluminium, and the formula is AlF3 3NAF. Now we discuss about the electronic concept of oxidation and reduction. What is oxidation? Oxidation is a process where an atom or ion loses electrons. Example, sodium, when lost 1 electron, it becomes Na positive. Calcium, when loses 2 electron, it becomes Ca double positive. Aluminium, when loses 3 electron, it becomes Al3 positive. What is reduction? According to electronic concept, reduction is a process where an atom or ion gains electrons. As for example, Al3 positive plus 3e aluminium, Fe3 positive plus 3e Fe. So the species which gains electrons and undergoes reduction is called oxidizing agent or oxidant, and the species which loses electrons and undergoes oxidation is called reducing agent or reductant. Now we discuss about the principle of Thermic process or Goldsmith Thermic process. Aluminium has strong affinity for oxygen at high temperature, nearly 1900 degrees centigrade. When oxides of relatively less reactive metals such as iron, manganese, chromium, etc. are heated with aluminium powder at a very high temperature, the oxides are reduced by aluminium to the corresponding metal in molten state. This is the basic principle of Goldsmith thermic process. And the reaction is 2Al plus Fe2O3, and the product is 2Fe plus Al2O3 plus 199 kilocalorie. That is, it is an exothermic reaction. A mixture of 3 parts of ferric oxide and 1 part of aluminium powder is called thermit mixture. 2 part of aluminium and 1 part of aluminium and 3 part of ferric oxide is called thermit mixture. Now, what are the applications of Goldsmith thermic process? There are several applications. We discuss about this. Number one is broken rails, broken machinery parts, etc. can be welded without removing them from their original sites by the application of Goldsmith thermic process. And the extraction of metal having high melting points, as for example manganese, chromium, etc. are extracted by Goldsmith thermic process. Now, when we discuss about metallurgy, there is a very important part. What is activity series of metals? What is activity series of metals? There is a activity series of metal. By this activity, at first we arrange the metal and their decreasing activity, or from bottom the increasing activity of the metals. The most reactive metals is potassium, sodium, after that calcium, magnesium, aluminium, zinc, iron, nickel, tin, lead, and hydrogen is non-metal. Below hydrogen there are some metals, as for example copper, mercury, silver, gold, platinum. From this series, these 5 metals, that is potassium, sodium, calcium, magnesium, aluminium, are highly reactive, and these highly reactive metals are extracted by electrolysis of molten ore of their respective metals. And the next group of metal, zinc, iron, nickel, tin, lead, they are moderately reactive, and extraction of metal, that is extraction of these metals by carbon reduction method from their oxide and carbonate. And the last, that is mercury, silver, gold, and platinum, these are less reactive metals, and these less reactive metals are extracted by heating their oxide. As for example, cinnabar, a sulfide ore of mercury, when heated in presence of oxygen, it produces mercury. The reaction is 2AgS plus 3O2, heat, it produces 2AgO, that is sulfide become oxide, 2AgO plus 2SO2, and this oxide 2AgO, when heated, it produces 2Ag plus O2, that is mercury. Discuss about the reduction of copper sulfate by zinc or iron. When zinc or iron metal is added to blue colored copper sulfate solution, zinc displaces copper from its salt, or iron displaces copper from this copper sulfate to produces either zinc sulfate or FeSO4, that is ferrous sulfate, and red copper is precipitated. However, copper is added to zinc sulfate solution, then no reaction occurs. Since copper is less reactive than zinc it cannot displace zinc from zinc sulfate. From this, we can conclude that a metal laying above in the reactivity series has greater tendency to be oxidized than the metal laying below it. Now we discuss about metal corrosion. What is metal corrosion? The deterioration of metals by the action of air, moisture, etc. is called metal corrosion. What are the favorable conditions of corrosions or metal corrosions? Number one, presence of oxygen and moisture. Number two, position of metal in the electrochemical series. Number three, presence of dissolved salts or acids in water which act as electrolyte or that enhance the ionization process. And the last one is presence of pollutants such as nitrogen dioxide, sulfur dioxide, carbon dioxide, etc. Now, what is rusting of iron? When an iron object is left exposed in moist air, it is oxidized to hydrated iron oxides, Fe2O3 and H2O, which is covered the original iron object as reddish brown coating is called rust. Preventing of rusting. Now, prevention of rusting. How can I prevent rusting? Number one, painting the iron surface prevent the rusting. Number two, applying grease or oil prevent the rusting. Galvanization is a process by which we can prevent rusting. Tin plating and chromium plating is also used to prevent rusting. Alloying the metals is preventing the rusting. And the last one, use of magnesium block is also used to prevent the rusting. Now the mechanism of formation of rust. First, iron acts as anode, impurities as anodes, and the water with dissolved oxygen act as electrolyte. The oxidation at anode is Fe solid to Fe double positive aqueous plus twice electron. Fe double positive become Fe thrice positive plus electron. And reduction at cathode, in acidic solution 4H positive aqueous plus O2 plus 4E is equals to 2H2O liquid, and the second reaction is 2H positive aqueous plus 2E negative, that is electron, is equals to or become H2 gas. Now in basic solution 2H2O liquid plus O2 plus 4 electron become 4OH OH negative in aqueous solution. Fe double positive plus 2OH negative, it is FeOH whole 2. 4 FeOH whole 2 plus O2, it become 2 Fe2O3 H2O plus 2H2O. This is the rust. Now we discuss about the corrosion of copper and aluminium. Number one, the copper surface develops green patches because of the formation of basic copper carbonate CuCO3 CuOH whole 2 or basic copper sulfate CuSO4 3CuOH whole 2 from copper on prolonged exposure to air. 2Cu plus H2O plus CO2 plus O2 becomes CuCO3 CuOH whole 2. Number 2, aluminium, that is the corrosion of aluminium. Aluminium metal loses its shine when exposed to air as because of the formation of aluminium oxide on the surface of metallic aluminium. This aluminium oxide so formed, that is Al2O3, on the surface of metallic aluminium prevents direct contact between the metal and atmospheric oxygen. Thus the metal actually become resistant to corrosion. Number 3, lemon juice contains organic acids, that is citric acids, which reacts with metallic copper, and soluble compounds of copper are formed. These compounds mix up with the juice and causes health implication. That's why one should not keep lemon juice in copper container. It is also applicable in case of aluminium or zinc. There is an important question: what is Wilson disease? This occurs due to abnormal metabolism of copper, and as a result, free copper in the plasma enters different tissues, binds with proteins, and get deposited in liver, kidney, and brain. This disease is known as Wilson disease. So, we have finished our chapter. If you have any doubt or you face any problem while going through my video, then please let me know. Write in the comment box. Hope you like it.